Hey guys, Mike here from Applied Engineering and Design, and I've got a quick tutorial for you on a really cool new feature of RhinoCAM 2015, which is their whole feature detection. So what I did here was I whipped up this plate. So say you just need a plate, maybe you're making a fixture plate, but you whip something up like this, whether it's a solid model, somebody else created it, and you need to set up the cam and everything. But what we're going to do is we're going to use the automatic hole feature detection to quickly machine this. So let's get started. Basically, what we've got here is I just drew up this extruded square, arrayed a bunch of holes in it, and it's ready to go. So we can do some videos maybe on some modeling as well if you guys are interested. But right now we're doing a bunch of these cam videos. So what we're going to do to get started first is, since I drew it kind of with the correct origin that I'm going to machine it in, we're good there, but we need to set our work 0 and set everything else up. So as usual, we'll go to our setup. We're actually just going to double click on this, make sure everything is good. And you can just check your axes arrows right there, and everything looks good. So we're just going to hit OK. We're going to create a stock. Double click on stock, and we're just going to click copy model bounding box, and you can see it's 6 by 6 by a 1/2 inch plate. So everything's pretty good there. And for whatever reason, there's this really small, minute number that pops up every once in a while. We're just going to go ahead and zero that out so that our corner is actually at 0. Going to hit OK. And if I show stock, you can see it's right there. We don't need to look at it right now, so we'll hide it. What we're going to do is going to go ahead and set a work 0. And our work 0 is going to be the top surface. We're going to say, I use a probe, so what we're going to do is we're going to probe, touch off the top, and we're going to touch off this bottom left corner. So our part 0 is going to be set to stock box, and you can see it kind of defaults to northwest. We're going to do southwest and highest Z, and that's basically what I just mentioned right there. We're going to check output work offset, and just for fun this time, we're going to change it up. We're going to use G55. So if we hit generate, it throws that in right there. Once our work 0 is set, we're going to come down here to machining objects. Normally you'd be working in your tool library, but we also have regions, features, and knowledge bases. So what we're going to do is come over to features. We're going to look at hole features. What this allows us to do is actually predetermine the hole features on this solid model. We've got 2 buttons here available right now. We've got a filter, which allows us to filter out diameters, and we've got the create hole features. So what we're going to do is we're going to hit create hole features, and it wants us to select the object. We're going to hit this flat surface right here, which selects that whole top surface, and we're going to right click. And you can see it automatically selects all the holes we needed and actually gives it a direction, and it's very cool. So it's pretty much ready to go. If we tick down the hole feature, we can see all 25 instances. Now let's say we want to eliminate a few of them, and we can see that right here, this bottom right is number 1, and it kind of counts up from there. So if we go ahead and select hole 5, you can see it's that one. Let's say we want to remove all 4 corners. So we're going to take hole 1, right click and delete. Hole 5, right click and delete. Hole 15 is the middle. Hole 9 is that one, right click and delete. And we're going to come down, hole 25 is that other corner. We'll delete that one. So basically what that did is it allows us now, if we select all, you can see it's doing everything but those outside holes. Maybe that's what we wanted, but it's really cool how you can kind of pick and choose what holes right from this feature. Next up, we want to create a machining operation to drill these holes. What we're going to do is we have 2 buttons now that are open. One is the create hole feature machining operation, and one will select a knowledge base to create the whole feature machining. So we're just going to go ahead and click the first one. Create whole feature machining operation. It's going to open up a dialog where it's got some information at the top. Now the instructions at the top are pretty much exactly what you need to do. It's very simple here. So what we're going to do is we're going to go ahead and select standard drill. We're going to drag it right over to the right. And if we tick it down, you can see it's got drill, feeds and speeds, clearance, and parameters. So what we want to do first is we're going to go ahead and take standard drill. And we can see that the pre-selects the top Z and the bottom Z. And we're going to go ahead right now. We're just going to see what it does. We're going to do create hole feature mop set. We're going to click it. What it did is it creates this feature over here for hole feature 1, creates standard drill, and everything, the control geometry, drill 1, and everything is all down in here. If we head back to our tool library, drill 1 has already been created for us. So if we double click drill 1, we can set up our tool. And let's say this is a 1/2 inch drill. We'll leave all the parameters. And we'll copy this to our comments. We use flood coolant. And let's just say it's tool number 1. And we can set our feeds and speeds as well. We'll just leave this all default for now. Hit OK. And we're going to save edits to tool. Hit OK. Hit OK again. And what we're going to do is we're going to right click and regenerate. And now you can see that it's created the tooling operation for everything. All the holes are selected. And you can see that the rapids are correct and the drilling is correct. So what we're going to do is now we're going to tweak it slightly. So let's go into double-clicking standard drill. And we'll go to tool. That's the correct tool. Our feeds and speeds. We're going to go ahead and hit load from tool since we changed it. Clearance plane. Good to go there. Our cut parameters, basically the only thing we want to change here is we're going to add the tooltip to the drill depth so it drills all the way through. And we're going to leave the sorting alone because it predetermined the sorting based on the hole feature, but you can change this here as well. We'll hit generate to fix that. Now you can see they kind of stick through the bottom there to make sure we got a nice clean hole. And we can go over to simulate. Shows us our stock here, and let's hit play. And just as we expected, it goes through and drills every single hole. You can see all the way through. This whole feature operation is very cool here. Allows us to do a lot of different things. If you have a solid model with a lot of holes like this, it would go ahead and pick them all. If we create a solid model with multiple different holes, it will actually create the hole features and determine the correct drill bits for the hole based on size. And we could actually, as you saw, let's say we want to go back in and create, for instance, we want to profile each of those and make sure the edges are clean. We can just come in here and do the same thing. We can drag 2.5 axis profiling, create hole feature, regenerate. Probably made an error here. It's trying to do it with the same size tool. So if we go ahead here and edit the tool, let's change this to a 1/4 inch diameter. And it's going to be tool 2. Save edits to tool. Generate. There we go. We're going to have a nice little profiling operation, clean up every single one of those. We simulate. You can see it goes in, zips around, cleans up each one. Very, very cool. Very, very fast for doing holes, and this is awesome for making fixture plates. I make a lot of fixture plates to hold various pieces of metal or Delrin or anything you're working on. If you got something where you want to make a plate full of an array of holes, the hole features are great for that. And you can rename them. There's a lot you can do. You can even create a knowledge base for the whole operation. Let's say you make a fixture plate and you know you might make more of these fixture plates. You can save it off as a knowledge base and recreate that fixture plate every time. So I think what we're going to do next is I want to demonstrate quickly the different size holes and how it'll do that for you as well. So I will come right back and I'll have a model with several different size holes. All right, guys, I'm back with a brand new model here. I know I edited the video together, but it doesn't take that long to put something like this together. So what we're going to do now is I've got a little model that's got a 1-inch hole in the middle, surrounded by 4 half-inch holes, surrounded by 6 quarter-inch holes. So we're going to go ahead and do the exact same thing. I'm going to walk you through it, and I'm going to show you how easy this is. So same exact way we did before. Let's create some stock, copy model bounding box, change this guy to 0, hit OK. In our setup, we're going to set our work 0, set to stock box, southwest, highest Z. We'll do G56 this time, generate. And we'll come down here into machining objects, into hole features. Now, we've got several different size holes. Let's say we only wanted to do the half-inch holes. We can come in here and turn on the diameter filter. Use diameter filter. Minimum diameter is going to be half-inch. Maximum diameter, half-inch also. And if we hit OK, when we go ahead and do hole features, it's only going to pick those. Very cool. All right, let's turn off the diameter filter. Hit OK. Let's delete this guy here. Come in, and we're going to do create hole features. Select it. Boom. How cool is that? You have 3 separate hole features for each of the different size holes. So you've got the quarter-inch holes, you've got the half-inch holes, and you got the 1-inch hole. So we're going to go ahead and create the machining operations for it. So let's start with these guys on the outside. We're going to do the full machining. We'll do spot drills. We'll do everything in one big jump here. So let's go ahead and do hole features. We're going to hit create hole feature machining op. And we're going to be in here and our hole features. We're going to go ahead and come down to, we're going to do standard drill. We're just going to spot it first. We're just going to drag it in there twice. And see if it'll let us change the drill to drill 2. No, I guess it won't. All right. So, but it's going to create it twice in there. It's going to allow us to change our drill depth and everything after the fact. So we're going to do create hole feature. Done. Go over to hole feature 2. This time we're going to do the same thing. Create hole feature machining operation. And we're going to drag standard drill in there twice. And this time let's save it as a knowledge base. And we're just going to call this holes spot and drill holes. Save. And we're going to created the second hole feature. This time what we're going to do is we're going to select a matching knowledge base. I guess it's only going to select it for that half-inch holes. We're going to load up knowledge bases if we had the hole machining ones. And it loads up that hole feature too, which is going to load up that exact same thing. So it's a cool feature. Looks like its limitations are exactly to that pattern and that hole feature, which is perfectly fine. If you had a full pattern, you could save all for that one hole. It would save everything about it. So let's go on to hole feature 3. We got the single 1-inch. We're going to go ahead and click create. And we're going to do the same thing. This time, what I'd like to do, it's a 1-inch hole. We're going to drag our hole profiling into it. And that's going to do it with a flat mill. And create hole. All right, so let's go double check everything up here and set all of our parameters. The hole feature 1 is going to have 2 standard drills. Let's change the name of this to spot. And come in here. First, let's take a look at what tools it created. Created a drill 1 and a flat mill 1. So we know our spot drill is going to be different. So if we come into tool, we're going to want to create a different tool for that. So under drill, say this is a 3/8 spot, tool size 3/8. And usually they're a little bit shorter, but we can leave this for now. So let's say that's tool 1. Turn on our coolant, come over to feeds and speeds. We're going to leave everything default on this, just change the size so it's correct. Hit OK. And we're going to save as a new tool. And it says the tool number is repeated because one of the other tools is set, but we're going to reset everything, so we're going to hit no here, so it does leave it as tool 1. Hit OK. Come into 3/8 spot, feeds and speeds, load from tool, clearance is fine, cut parameters now. So now this is a spot drill. So we can either use countersink drill and give it the approximate countersink diameter we want. You know, for all intensive purposes here, a lot of times I'll just do a standard drill and set it to just spot at 50 thou, just to kind of get it started. We're going to hit generate. You can see that if we zoom in real close here, that it only kind of drills slightly into there. If we go into our standard drill, I'm going to change the name of this to drill 1/4 inch. If we double click, tool, we're going to leave this drill 1 here. Now let's go ahead and change the name of this to 1/4 inch drill. Change the diameter. This is going to be our tool 2. Turn on flood coolant. Set our feeds and speeds. Now as a 1/4 inch drill. And our max RPM on this machine is going to be 12,000, so we'll change it to that. Hit OK. Save as new tool. We're also going to hit no here. Hit OK. Make sure our 1/4 inch drill is selected, feeds and speeds, load from tool, clearance plane, cut parameters. So now we're going to drill all the way through. We know it's a 1/2 inch block. We're going to add our tool tip to depth so it drills all the way through. We're going to hit generate. Good to go. So now this still looks like it's dirty here. If we right click and regenerate everything, we're good. So all of those holes are perfectly done. Let's go down to hole feature 2. Now we're going to do the same thing. We're actually going to call this spot again. Go into it. Tool is going to be the 3/8 spot. Load from tool. Cut parameters, we'll change to 50 thousandths. Generate. So that's spot. Come in here. Now we're going to drill 1/2 inch. Come into the tool. And we're going to edit this tool. This time we'll actually edit this tool and call it a 1/2 inch drill. Leave everything the same. Turn on some coolant. This is going to be tool 3. Feeds and speeds. Everything's going to be correct because it's now 1/2 inch. Hit OK. And we're going to save as edits to that tool. Hit OK. OK again. Feeds and speeds, load from tool. Clearance is fine. Cut parameters, same thing. Turn on drill depth, tooltip to drill depth. Hit generate. Got some holes. Come back up here, regenerate it all. This one's good. Now if we come down to our hole feature 3. Now we're going to just profile this hole all the way down and basically drop a slug out of it. So if we come into the hole profiling, tool is now we got a flat mill. So it's a 1 inch. So what we're going to do is, let's say we're going to work with a 3/8 end mill. So come in here and do 3/8 end mill for our description. Change the diameter to 375. And we're going to make sure our flood coolant's on. And now this is going to be tool 4. Feeds and speeds, we're going to come in here. And we're just going to change our diameter as usual. And we are going to use a 2 flute end mill here, for instance. 12,000 RPM is our max. Hit OK. Save edits to tool. Hit OK. And feeds and speeds, load from tool. Clearance pin, same dialog, nothing to change here. All right, so now our cut parameters here. This is where we got to make a couple changes. So our tolerance is going to stay 1 thou. Our hole depth is a 1/2 inch. And what we can do is, I would probably set this to like 600 thou, just so that it goes all the way through and cleans off any burr that might be at the bottom. And the hole diameter is already set to 1, which is correct for this. And the checkbox is already set for using the arc diameter. And it's set to conventional upcutting, or you can set it to climb. Not a big deal. And what you can do here is adjust your helix pitch, your actual height between them. So we're going to leave this alone for now. And our entry exit, we don't actually, we can let this see where it is for our entry and our exit, but I have a feeling it's going to cut into our stock here. So let's leave it alone. That way we can show if something does happen, how you can go in there and fix it. So we hit generate, come back in just like the other, regenerate it. And if we take a look here at our toolpath, everything looks pretty good. So I don't think we have anything to fix, and you can see it spirals its way down. And why don't we simulate it and take a look at how everything looks. So we'll start right from the beginning. We'll hit simulate. You can see our stock here, and we'll hit play. So it's spotting all those, drilling our 1/4 inch holes, spotting the halves, drilling those, and it's spiraling down to get rid of that. And you can see that it basically cleaned out that entire hole, and that slug would fall out. There you have it. That is a quick and dirty tutorial on using the hole features. I really like how this works. I make a lot of plates like this for whether it's mounting pieces of metal for working on knives, or different ways to mount things to the table for some of my different clients. So great way to make fixture tables. You can use the hole profiling for anything if you got a lot of holes on a product. Or things you need to drill. But I think RhinoCAM 2015 did a great job in this automatic hole feature detection. So once again, if you got any questions, feel free to hit us up at info@appliedengdesign.com, or hit me up on Google, or find us on Facebook or Twitter, Applied ENG Design as well, with any questions or any ideas you have. So make sure you subscribe to the YouTube channel, and we'll catch you on the next feature. Thanks, guys.